So welcome back to the next appointment of Schlumberger Academy, and today we are focusing about the trouble of PLT log, production log. So production log is not so easy to make interpretation and to find the correct answer to whole question, because especially in supercritical and subcritical geothermal reservoir with high pressure and temperature, the condition and the mixing flow is really complex. So we have also this condition when we using geosteering drilling techniques. For example, when we have a shale gas or a shale gas reservoir. If you use geosteering technique to drill and to extract gas, for example, we can have also this kind of problem, because instead of near vertical well, in near vertical well is too easy to have a separation between oil and water mix. When we make, for example, we have this condition. When we have a deviated well, so generally we try to have a corrosion phenomenon, because all the most density particle, for example oil, try to impact to the upper surface of well, and there is a high complex flow structure, water phase and bottom of pipe. The surprise in oil phase in the uppermost level of pipe, new horizontal well, almost stratified flow structure, oil at the top, water at the bottom, and a mixture of top in the middle of pipe. It's generally clear that this condition can be evaluated also, for example, in schematic depth temperature plot, also in geothermal resource. So today we are talking about especially of this first parameter, productivity index flow and performance. When we are talking about productivity index parameters, PI and flow performance, we generally use instruments for PLT and to measure inflow performance. Spinner flow meters, purpose, working principle. The working principle of spinner flow meter is use a rotating spinner or impeller rotational speed correlate with flowed velocity. Output flow velocity, so in this case when we are analyzing flow velocity, is really interesting to analyze the velocity of flow that comes through wells, to estimate the impact also on the part of wells, but also the all mechanical part and all establish, for example, the corrosion or not. Pressure gauge, measure static and flow bottom hole pressure. Output pressure, PSI and bar. Temperature sensor, identified zone of fluid entity based on temperature anomalies. Output temperature profile, else detects in flow zone. What about also journey to estimate productivity index? We journey is an optional, is not imposed, but is really recommended. Is to use gamma ray log. Gamma ray because the purpose is lithology identification and make correlation and helps to correlate inflow zone with formation. So establish for which formation, which geological formation comes the oil gas. Noise log, so is like an acoustic log, but inverted, in that it means that we not measure the acoustic, but only we register the noise. So if we have some detected elevated noise, we have a high volume of fluid. Detect fluid movement by recording acoustic signal. So this is techniques to likes monitoring the inflow gas or oil in wells. What about the productivity index? Productivity index is established with an equation, PI. Q is like Q, Q, that is a production rate, for reservoir pressure, for down pressure. And down pressure is a result of difference between reservoir pressure and flow buttonhole pressure in PSI or bar. The inflow performance relationship that is called IPR. This flow values in bottom hole pressure for wells. It's often modeled by Volge equation, and for example Q minus Qmax is in a range of value between 1.1 and 0.8. Generally is a recommended value. About the productivity index and the PLT logs. PLT logs helps to detect zone that contributing to flow using spinner and temperature, because the parameters to monitoring is always temperature and pressure, also in oil and gas. Measure velocity and converter to rate using flow interpretation. Combine rate, pressure data to calculate PI per zone and for the whole well. Flow calculation from spinner logs, where flow velocity are for cross-sectional area and well bore, and is spinner, kappa is calibration factor. So the flow rate calculation for spinner log is established by this relationship. But what is most important is how to use the production log, PLT logs. Is really important in establish the productivity index P and flow performance, because through PLT logs we try to detect the zone and geological area that have a high contributing to inflow of oil or gas, and establish the velocity of inflow, convert to rate also, using flow profile interpretation with this formula. It's clear we convert to rate with this formula. And so we have also the flow rate calculation. Generally the production log, the equation are the following, because we have a production index P that is also referred to a ratio between the production log index. We can mean that is a ratio between the inflow and the difference of pressure, initial pressure in reservoir and final pressure, is I will just explain in the previous slide. As you just explained in the previous slide, so we have here, okay, so is a ratio between production rate, SB per day, or meter cubes by day, ratio between this value and this difference, reservoir pressure, flowing bottom hole pressure. We have also other parameters also established by production log equation. This like bubble rise velocity is simplified. Spinner calibration, Q calibrated in this way, and also single phase production ideal, And we have another equation, is most important equation when we make when we make a geosteering project to capture along a single layer the inflow horizontal well, is that and is that. And so we are also showing an example of coding and how we perform horizontal layer inflow. Ed è in questo video che appunto, e quindi in questa parte qui vi mostro il codice realizzato appunto per un'operazione di geosteering, so is a geosteering operation along 3000 meters in horizontal wells, so we can choose the length of horizontal well, in case the value is 5000, but the real value is under 7000, 7000 value. We have a number of segments, in this case we have 20 segments. The initial production rate is 4000, and to apply. Distance decline rate is 10. And we have also zonal identification, is the input parameters that you can choose. In this case we have sequences in a convention reservoir based on shale brick and tar sands and shale brick, tar sands and shale brick. We have this repetition, and finally we can have the result of inflow forecasting time with MOV. So is a plot, is a provisional inflow forecasting 15 months, is around 4 years, and there is the well zone statistic, well zone assessment for the single zone, this, and we can export all data in CSV format. Thanks for attention. See you to next appointment at Sumager Academy. In next appointment we talking about the other parameters, the spinner and outspin calibration, single phase of two phase, and so we are show how can simulate a single phase or two phase when we have in oil and gas, for example, the mixing zone between water and oil, and we have also which parameters we need to consider. And we have also a focus on geothermal application, because in geothermal application we have always it's impossible to have a single phase, because always we have two phase, two physical phases, steam and water, steam and water, steam and water, and also mixing, for example, with lithium and EV metal. Thanks for attention.